Good morning, students. So the closing door is required. So all of you have practiced with respect to IPSC nomenclature, right? Fine. So in that case, we will move to the next concept. But before going for that, what and all we have discussed with respect to organic chemistry, right? So what was the first concept we have discussed in organic chemistry? That is related to classification. Classification of an organic compounds. Classification of organic compounds. Right? So that's what we have discussed. Classification of organic compound. Then what we have discussed? Then we have discussed about different ways to write the structure of a molecule. To write the structure of a molecule, right? Structure of a given organic compound. So that's what we have discussed. And then we were talking about IUPAC nomenclature. Then we were talking about IUPAC nomenclature. Right? So that's what we were discussing in the last classes. Yes, homologous series. Yes, even we have discussed about the homologous series. Yes, Gauri, absolutely correct. So these are the some of the concept which we have discussed in the last class. So whether all of you can see whatever I have written on the board? Whether all of you can see whatever I have written on the board? Just send me yes or no. Okay, because I can see the charts. So whether all of you can see the board? What and all I have written, no doubt. Okay, done. So that's what we have discussed in the last class. Now today we are going to talk about classification. Classification with respect to isomerism. Okay, so we are going to start with the important concept. One of the important concept, that is isomerism. That is nothing but isomerism. Right? Isomerism talks about study about the isomers. It talks about the study about the isomers, right? So hagadre, when I am talking about isomers, already I have discussed this one. Okay, isomers are those organic compounds which are having same molecular formula but differs in their structure. Right? So in that we have discussed about one type we had started, that is structural isomerism. That is structural isomerism. If you remember, one is structural isomerism. Which one was the another category? Another one was stereoisomerism. Stereoisomerism. We have two types in isomerism. So one is structural isomerism and another one is stereoisomerism. Same logic can be applicable even for isomers also. Even in isomers we have structural isomers and stereoisomers. Isomerism is a process. Okay, isomerism is a process, and isomers, then we are talking about the molecules. So isomerism is a process And isomers, we are talking about the molecule which is showing the isomerism. No confusion, right, among these two words? Fine. So this is related to process, this is related to molecules. So structural isomerism, we are talking about the process. Stereoisomerism, we are talking about the process. Same way we can tell that structural isomers, we are dealing with the molecules. Stereoisomers, we are dealing with the molecules. Okay, all of you have understood? So, when I am talking about structural isomerism or structural isomers, so that's where they differs with respect to their structure. They differs with respect to their structure. Molecular formula will be same, but they differs with respect to their structure. Okay, so that's where we have the structural isomerism. Structure. Rakesh, board is not clear. It's blaring. For all of you, 1 minute. Now, whether it's clear? Now, whether it's clear? Okay. Okay. So, Rakesh? Okay, done. Okay. Okay. So, however, when I am talking about structural isomerism, that's what I was telling. We are going to discuss about different category in structural isomerism. So, in that way, we have one of the classification which is called as chain isomerism. Chain isomerism. So, that is one category. Then another category is positional isomerism. Positional isomerism. Okay. Then we have the functional group isomerism. Even about functional groups, we have already discussed. Yes, functional group isomerism. Then we have the metamerism. Then we have the metamerism. So about this particular part, many times they have asked in the examination about whatever we can't see you, sir, only audio. Okay. So even for me, only chat I can observe. Everyone for the same problem, everyone. For everyone, it's I'm only audible. No video. Okay, 1 minute, 1 minute, 1 minute. Even for me, I can see the chat, the video screen, but I thought they are unvisible for me. Don't waste time. Now, this is from the beginning it was there, but now for them also. Now all of you can see. I just asked. Yes. Okay. So I think okay. Now it's visible, right? Okay. Done. Done. Sorry, there was a problem with mobile. Okay, na? Prithvi, I think it's everyone they are telling they can see me. Can you rejoin? Prithvi, can you rejoin? Okay. So just rejoin once again. There might be a network issue from your side also. Okay, okay, okay. So that's where I was talking about structural isomerism. Board is not clear. Okay. Hmm. Now it's clear, Appa. Board is not clear. What to do? Now whether all of you can see the board properly? Okay. Okay. So Geeta and Rakesh, now whether it's clear? I have reduced the brightness, means light I have put it off. Now whether board is visible? Okay. So Ashish, I don't know how to increase the resolution, but I think uh, Mayank has kept it high resolution only. Okay, na? Fine, fine. So that's what I was telling. Chain isomerism, positional isomerism, functional group isomerism, then metamerism. So these are the four categories which comes under structural isomerism, and with respect to your examination point of view. No sir, he is telling others. Okay, okay, okay Rohan. Ashish, I got the point. Okay. So structural isomerism, this particular part, it's very important for your exam. They have asked many times. They have asked about these things many times. Okay, na? So when it comes to stereoisomerism, as we have discussed, we have geometrical isomerism, geometrical isomerism, and then we have the optical isomerism. Then we have the optical isomerism. Once again I will tell, on the right side, for first PU it's not there, don't worry. In second PU we'll study about these things, especially optical isomerism, with respect to one of the topic called as biomolecules. In second PU, organic chemistry. Okay. So yes, Gauri. So that's where we have optical and geometrical isomerism, which are the example for stereoisomerism. But when it comes to structural isomerism, so that's where we have the chain isomerism, positional isomerism, functional group isomerism, and metamerism. All of them, they are important. All these four, they are important. Okay. So one by one, we are going to discuss about with this classification with example. In the examination, if they ask definition and then if they ask about the example, then you have to explain, you have to define, then you have to talk about examples also. Fine. So hagadre first one is chain isomerism. First one is chain isomerism. So I will increase the font size a bit so that you can see the board properly. Okay. So first one is chain isomerism. Hagadre, when I am talking about chain isomerism, in the name itself it is there. These are the organic compounds. These are the organic compounds. Organic compounds having same molecular formula. Having same molecular formula. Having same molecular formula, but differs with respect to but differs with respect to. You use the full form. Here I have used WRT, but you can use full form only with respect to arrangement of the chains. Arrangement of the chain. Arrangement of the chain. Okay. Parental chain, to be more specific. Parental chain. So that's where we have the chain isomerism. Okay. So what do you mean by chain isomerism? This is a process where chain isomers will be involved. So hagadre what do you mean by chain isomers? So these are the organic compounds which are having same molecular formula but differs in the arrangement of their parental chain. So that's where we have the chain isomerism. If I give the example, you will understand it properly. If I write the examples, you will understand it properly. Shall I remove this one so that I can go with the examples now for chain isomerism or chain isomers. So shall I remove this? Okay, any doubts with regard to definition of chain isomers? Okay, so when I am talking about the example, where one of the example can be CH3, CH2, CH2, CH3. Which is this molecule? Can any one of you tell me? What is the name of this molecule? Whatever I have written on the board. Anyone? What is the name of this molecule? Any one of you can tell me? Okay, yes, girl, it is butane, or to be more specific, I can tell that N-butane. You are right. Since it's a linear chain, I can tell N-butane. Okay, all of you are right. It is butane. Now, I will write another molecule. I'm going to write the another molecule CH3, CH, CH3, CH3. So now, what is this molecule? Which is this molecule? Second one. Which is this molecule? So this is first one. Now whatever I have written, it is second one. Which is that one? Can you name the molecule? Isopropane. Okay. Rohan is telling it is isopropane. So whether Rohan is correct? Rohan, if you want to talk about iso, then you should not use the word propane. It is isobutane. Since you are talking about iso, it should be isobutane because 4 carbons are there. It's 4 carbon containing molecule. 1, 2, 3, 4. So isobutane 1, 2, 3, 4. Same as that of the butane molecular formula. So therefore it should be written as isobutane. What my point, Rohan? So propane you can write if you are talking about IUPAC nomenclature. For example, I can write this one as 2-methyl propane. 2-methyl propane. So isobutane or 2-methyl propane, it is one and all same. Isobutane or 2-methyl propane, it is one and all same. Isobutane is a common name. So 2-methyl propane is the IUPAC name. Got my point, Rohan? If you want to talk about propane, then you should talk about IUPAC name. If you are telling iso means it should be similar to butane because it's a 4 carbon containing molecule. So this can be the example for chain isomers. So isomerism, chain isomerism is a condition or a process where molecules differs in their arrangement of the parental chain. Chain isomers are the group of organic compounds which are having same molecular formula but differs in their parental chain arrangement. So that's what we can see. So molecular formula is same. What is that molecular formula? 1, 2, 3, 4. C4. So 3 plus 2, 5. 3 plus 2, 5. H10. That's where we have the molecular formula. What about here? So 3 plus 3, 6 plus 4, 10. So C4H10. So they are having, both of them they are having same molecular formula. But if you observe the parental chain, they differ. Here it is 4 carbon. Here it is only 3 carbon. What my point? All of you have understood, right? This can be one of the example. Or you can go with other examples which is there in your textbook where they have taken pentane derivatives. Pentane and pentane derivatives. Even this can be the example. Butane, isobutane. So if I go with pentane, the number of isomers they are going to increase now, right? Say for example, CH3, CH2, 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 then CH3. So which is this molecule? This molecule should be N-pentane. This molecule should be N-pentane. Now, I'm going to write the another form of same molecule, another structure. CH3, CH2, CH3. So this is isopentane. This can be isopentane. Now, N-pentane. It can be a common name or it can be a IPAC name. But when I'm coming to isopentane, IPAC name can be so 2-methyl butane. 2-methyl butane, IPAC name. So N isopentane and 2-methyl butane, one and all same. Now another form we can write, that is CH3, CH3, CH3 and CH3. This is called as neopentane. This is called as neopentane. Now if I want to write the IPAC name for neopentane, so what I can write? What can be the IUPAC name for neopentane? So neopentane, parental carbon can be a propane, like this or like this. So I can mention it as 2, 2 dimethyl propane. Now if you see the IUPAC name, you can see the difference in there. Yes, Rohan, very good. You can see the difference in that parental carbon chain. Here it is pentane, parental carbon. In second case, it is butane, parental carbon. In third case, it is propane, which is with the parental carbon. So that's for another example for chain isomerism. Another example for chain isomerism. As the number of carbon increases, number of chain isomers can be more. All of you have understood? So that's where we have the chain isomers or chain isomerism. Now, I have a question whether propane can show chain isomerism. Whether propane can show chain isomerism? Anyone? Whether propane can show the chain isomerism? Propane. Gauri, she is telling yes. All of you will agree with her? Okay. So when it comes to parental chain, no. Propane will show the isomerism, no doubt. That is N-propane and cyclopropane. But when it comes to parental chain, no. Because propane is having only 3 carbon. there is no option to have the different parental chain. But when it comes to butane, then onwards they can show the chain isomerism. Then onwards they can show the chain isomerism. Got my point? Then another one is positional isomerism or position isomerism. Or we can talk about isomers. Anything is fine. Okay, Gauri. Sorry, I thought you gave the answer. Okay. So position isomerism or positional isomerism. Now we are coming to the next one. Now in the name itself it is there. It is talking something about the position. So position of what? Position of a substituent with respect to the main chain. Position of a substituent with respect to main chain. That's where positional isomerism is there. What do you mean by positional isomers? So these are the organic compounds. So these are the organic compounds having same molecular formula, but differs with respect to I'm using WRT, better you can use the full form. So but differs with respect to position of the substituent, substituents to the main chain, to the parental chain, So that's where we have the position isomerism. Now, one thing I will make it clear, it can be a substituent or it can be an unsaturation, whatever it is. But we are focusing on substituents here. But we have a condition where even there will be differs with respect to position of unsaturation. That one also you can mention. Substituents or unsaturation with respect to the parental chain. All of you got my point? Any doubts with respect to this definition? Just you can add it here. Substituents or unsaturation. If I am talking about alkenes, if I am talking about alkynes, so that's where we can include unsaturation. It can be a substituent or it can be a unsaturation with respect to main chain. Fine. So any doubts with respect to definition? Now can we go with examples then for position isomers? Okay. Now when I am talking about position isomers, examples can be CH3, CH, OH, CH3. Okay. Now another way we can write. Okay. We can talk about here CH3, CH2, CH2, OH. So they can be the examples, right? So now when I am talking about this molecule will be considered as isopropanol. Isopropanol, a common name, isopropanol. Or if I want to talk about iupacinane, then I can tell that propan 2R. Propan 2R, where propane is removed by OL. So propan 2R. So what about this one? This one simply can be written as N-propanol. We can simply written it as N-propanol, where it's understood that OH group is attached to terminal carbon. Or simply we can write it as propan 1R. Propan 1R. All of you got my point? Propan 1R. Now that's where the differs with respect to position of OH group. In this case, OH group is present at second carbon. In this group, OH group is present at first carbon. So that's where we have the difference in that position with respect to OH group position with respect to parental chain. Right? So what is the molecular formula for them? So 3 carbon. So 3 plus 1, 4 plus 3, 7, 8. So that means C3H8O. Right? So same thing is applicable here also. So 3 plus 2, 5, 5 plus 2, 7 and 8. So C3H8O. So that's where they are having same molecular formula. They are having same molecular formula, but they differs with respect to position of OH group. What my point? So this can be the example for position isomers, or you can take even butane derivatives where OH group will be present at different positions, or pentane, anything you can take where you can show the different position of OH group. Or I can take with respect to unsaturation. CH2 double bond CH, CH2, CH3. Okay, so this is one alkene. So which is that alkene? Can you name the molecule? What is the name of the alkene here? Which alkene it is? Any one of you? Which alkane? Fast. So it can be butene. It can be butene. Okay, now you people have written. Yes, Ashish. It can be butene. Right? Because 4 carbons are there. But since there is the unsaturated, it should be an alkene. So butene. Or to be more specific, I can tell that butan 1E. Okay, so butan 1E. So that can be, or but 1E. That is also fine. But 1E. That is also fine. So that's where we have the butene. On the other hand, I have CH3, CH, double bond CH, CH3. Right? So that's where we have the condition. Okay, here I write it as but 1E. So here it can be once again but 2E. But 2E. But my point? So they are the positional isomers. They differs with respect to position of double bond. They differs with respect to position of double bond. So but 1A, but 2A. Right? So that's where the position of double bond they differs. So what is the molecular formula? So naturally it will be C4. Then we have the 3 plus 5. So it will be because we are talking about alkenes. C4H10, it is related to alkanes. So minus 2. So it will become C4H8. Okay, now same thing is applicable here also. It will be C4H8. So that means both of them they are having same molecular formula, but they differs with respect to position of double bond. Okay, so naturally it is C4H10 for alkane, that is butane. So minus 2, C4H8. So this is another example for position isomers. This is another example for position isomers. Okay, now next one. Next one is functional group isomerism. Next one is functional group isomerism. Okay, so in this case, when I'm talking about functional group isomerism, I can tell that these are the organic compounds. These are the organic compounds. These are the organic compounds which differs with respect to functional groups, which differs with respect to functional group, but having same molecular formula, but having same molecular formula. Sorry, but having same molecular formula. Okay, so that's where we can define it. So what I mean by functional group isomers? So these are the group of organic compounds which are having same molecular formula but differs in their functional groups. Okay, na? So examples. If I want to go with the examples, naturally it can be a ketone and an aldehyde, which can be given as an example. A ketone and the aldehyde can be taken as the example. Okay, na? So I have CH3, CO, CH3. Okay, so common name here it is acetone. It is called as acetone. What is the IUPAC name? IUPAC name will be propanone or propanone. Understood that at second carbon there is a ketone group. At second carbon it is a ketone group. At terminal carbon, ketone group cannot be present. So when I am writing propanone, it's understood that at second carbon there is a ketone group. Okay. Now another molecule can be CH3, CH2, CHO, or same thing I can write it as CH3, CH2, CHO. Anything is fine. Okay, all of you have got point. So which is this molecule? This should be propanol. AN. So that means one is aldehyde group containing molecule and another one is ketone group containing molecules. But both are propane derivatives. So both are propane derivatives. Okay, so that's what. E will not be there, Gauri. It is propanol. Propanol means then we are talking about an alkyl. So it is propanol. Okay, na? So that's where we have the two molecules. What is the formula? So here it is C3, then 6 hydrogen, right? And 1 oxygen. C3H6O. So what about here? So here also it looks like C3, 3 plus 2. Okay. So therefore H6O. So they are having same molecular formula, but differs in their functional groups. Totally different molecules. So one is a ketone and another one is an aldehyde. But they are having same molecular formula. So therefore, this can be an example for functional group isomers. Fine. Okay, and the last one is metamerism. Last one is metamerism. Okay. Now, when I'm talking about metamerism, it's normally applicable for the ethers, a type of organic compound which is called as ethers. So, Hagan, what do you mean by ethers? Anyway, in detail, you are going to study this one in your second period. One separate topic is there with regard to the ethers. So, what do you mean by ethers? These are the organic compounds which are having this type of linkage, where oxygen is present between two carbon. So whichever molecule is having this particular linkage, they can be considered as ether linkage. They can be considered as ethers. But my point, and ether is can be those organic compounds which will having the special features, special properties. Okay, na? So, when I'm talking about these ethers, we have a compound where CH3O CH3. Okay, CH3O CH3. So, this is one compound. Now, with regard to this molecule, I can tell that it is methoxymethane. It's a very simple. So, alkoxy. What do you mean by alkoxy? OR. So that's what I can see. Alkoxy group, which is attached to a methane. By removing one hydrogen from methane, alkoxy group has been attached. Okay. So which is that alkoxy group? That is methoxy group. So therefore, this is methoxy, just like alkoxy, and this is a methane derivative. That is methyl. Therefore, we can call it as methoxymethane. We can call it as methoxymethane. All of you have understood? That's how ethers will be named. That's how ethers will be named. Okay, na? So, correct? If I take, this can be one of the example, not for metamerism, just for organic compounds and type. Same way, I have C2H5O C2H5. Can anyone tell me what can be name of this particular molecule? Methoxymethane, I have discussed. What will be name of this particular molecule? Or to be more this one, I can write it as CH3, CH2O, CH3, CH2, CH3. Same thing, I have written down. What can be the name? Methoxy. There is no methoxy group, right? So it should be ethoxy. Observe it carefully. It should be ethoxy. Because two carbon, therefore it should be ethoxyethane. It should be ethoxyethane. Ashish, methoxyethane is not possible. No need to delete. Don't worry. No need to delete. You people have attempted. I appreciate that. Okay, na? So that's where we have the ethoxyethane. So this is nothing but two carbon. Therefore, it's an ethane derivative, right? Ethyl group. Can you observe here carefully? So CH4 methane, CH3 methyl. ಅದೇ ರೀತಿ C2H6 is ethane. Then C2H5, it will be ethyl. Same thing I have written here. So it is a ethane derivative. It's a ethane derivative. Don't get confused. Okay, na? So therefore we can call it as ethoxy. ethane. Ethoxyethane. Okay, we can call it as, yes, Gauri, we can call it as ethoxyethane. Got my point? So C2H5 with one bond means I am talking about ethyl group which is derived from ethane. So therefore, this one I will consider it as an ethane derivative and this one as an ethoxy. So ethoxyethane. So ethoxyethane. Just like methoxymethane. Okay, na? Another doubt see there. So that's where we have the ethoxyethane. I will write another molecule. You should tell me CH3O, CH2, CH2, CH3. Which is this molecule? Now I will give a hint. Name of the molecule should ended up with a longest parental chain carbon. Name of the molecule should ended up with longest parental chain carbon containing molecule. That one. You should name the molecule ethers in such a way that we have to take a longest parental carbon as the name of the molecule. Then what will be the name of that molecule? What can be the name of that molecule? Right one. This is ethoxyethane. That one. Here both are having two carbon on both the side. Okay. So therefore ethoxyethane. There ethoxyhexane. Manjunath is telling ethoxyhexane. Manjunath, how come hexane? Any six carbon over there? No, there is no six carbon. Total carbon itself it is four. And in between one oxygen is there. So naturally it is not a butane also. Propanoxymethane. Yes, Bhumika. You have attempted. Very good. Even Manjunath. No need to feel anything. So even if people have attempted, now I can tell that even instead of telling propanoxy, as I told, name of the molecule should be given with higher number carbon containing molecule. So therefore, higher carbon is here propane. Ashish, wait. It's not butane. It cannot be butane because in between oxygen is there. They are not in continuous linkage. Okay. So therefore, I can consider this one as a propane derivative, that is propyl group. Can you see? And this one as methyl. Try to understand this one properly. Okay, this is a methyl group and this is propane derivative. What is propane? CH3, CH2, CH3. But here it is like CH2, CH2, CH3. So just like methane will become methyl, same way propane will become propyl. So here it is a propyl group, but it is a propane derivative. So longest carbon is with respect to propane because methyl is having only one carbon. So I will make it as methoxy. I will make it as methoxypropane. I will write it as methoxypropane. So propane I will take it as a parental chain. Propane I will take it as a parental chain. That's what we will do, right? Selection of the main chain or parental chain. That's what I did. If you go back, IUPAC nomenclature, alkoxy group always it will be used as a prefix, not as a suffix. All of you have understood. So alkoxy group it will be used as a prefix. So name of the molecule should be alkoxy and name of that molecule, parental chain. So therefore ethoxyethane, methoxypropane, because propane is having three carbon and methyl group is having only one carbon. So longest carbon is propane. So therefore methoxypropane, because alkoxy group will be used as a prefix, not as a suffix. All of you got my point? Okay. So therefore it cannot be propaoxy. It should be methoxypropane because methyl group is having less number of carbon compared to propane. Okay, so that's where we have one molecule which is an ether and which is an example for symmetric ether. It's an example for symmetric ether. Why it is called as symmetric ether? Because on both the side of the oxygen, they are having same alkyl derivatives. On both the side of the oxygen, they have the same alkyl derivative. Okay, but when it comes to here, it is an example for asymmetric ether. It is an example for asymmetric ether. Why asymmetric? Because on one side it is methyl and on the other side it is propyl, different. So therefore asymmetric ether, symmetric ether. But if you observe them carefully, they are having same molecular formula. They are having same molecular formula. For example, so total carbon is C4 and total hydrogen is 10, right? Oh. C4H10O. Got my point? So what about here? So here total carbon is 4. So total hydrogen is 10 and 1 oxygen. So C4H10O. So that's where we have the example for metamerism or metamers. So what do you mean by metamerism or metamers? These are the organic compounds which will be having different groups on the side of the ethers, which will be having different groups on the side of the ethers or functional groups, any of the functional groups. So they are called as metamers. So what do you mean by metamers? So these are the organic compounds which differs with respect to substituents on the either side of the functional group. In this case, ethers has been taken as an example. Okay. So differs with respect to substituents on the either side of the functional groups. They are called as metamers. They are called as metamers. Any doubts? All of you have understood this one? Anyway, I will stop here. Okay, all of you have understood. So what do you mean by metamers? So these are the organic compound having same molecular formula but differs with respect to substituents on the either side of the functional groups. In this case, I have taken as a ethers. Okay, na? So any doubts? Okay. Sir, can you give some more examples? Oh, we will have a discussion on it. Tomorrow we'll have a discussion with some more examples. Okay. In that case, I will stop here. Thank you. Take care. Okay, na? Thank you. Thank you. Bye. Where is Dikshit? Not to be seen. Okay, thank you. Thank you very much.